Hello, everyone. Thank you for joining us today. My name is Kelly Hall, and I'm a marketing coordinator for ALS North America, and I'll be facilitating this webinar today. Our presenter today is Madison Don. Madison has a Bachelor of Science in Chemistry from the University of Arizona and received her MLA, or the Machinery Lubricant Level 1 certification last year. Madison has worked for ALS for almost 4 years as a lab technician and laboratory supervisor. And currently, she is the Phoenix Laboratory Manager for Tribology. Madison, thank you so much for taking your time to deliver this presentation today. I will go ahead and turn it over to you.
Hi, thanks, Kelly. I'm really excited. Today we're going to kind of be talking about viscosity. I'll go to my next slide to just kind of get into what viscosity is. It's one of the most single most important characteristic of lubricating oils. We say this mainly because oils are used to just really reduce friction or really help with film thickness when you deal with your equipment. And so it's key to the equipment world. So when you kind of look at what viscosity is, it's the fluids resistant to flow with respect to temperature. So when you think of colder temperatures, and you can think of this in terms of water as well, but we're going to think of it in terms of oil, you start to get something that's a little thicker, a little harder to work with, and it kind of pours different. Think more like maple syrup, where when you get to high temperatures, it very much thins out. It starts working a little different. And when you're pouring this, you're looking more at water. And now these are not always going to say that that's always how it's going to be. It depends on what kind of grade you're looking at when you're doing it. But viscosity is used to that oil is used to help with friction loss and oil film thickness. And so when we talk about oil film thickness, we typically have 3 to 4 general areas. And so we have boundary thickness, mixed thickness, and hydrodynamic. And so as we work our way down that list, film thickness increases. And so when you're looking at a boundary thickness, that's when you kind of see 2 metal plates rubbing against each other, and you have a lot of friction that's going on there. And so it's oftentimes associated with metal to metal. So that's where you would see that mostly when equipment's starting, or when you're having stops, or even when you have a lot of shock with what you're using. When we get into mixed, that means that your equipment's kind of been running, or you start to see that thickness increase. And when I say thickness increase, there's a separation between your 2 components that are being created, and you see more sliding going on and less friction. When you get to hydrodynamic, you're seeing a full film layer of oil support, and that's also at full speed conditions, and that's what you're really working towards. But the reason I kind of go into this oil thickness is that's going to be how you decide if your oil's working correctly, as well as if you selected the correct oil. And all that's important when we start to look at viscosity as a whole, and we start to look at analysis. So as your changes in viscosity occur, it starts to affect your lubricant performance and stability. So if you have a contamination that is changing your viscosity grade, or your oil type that's either making it thinner or thicker, you start to see that in how it works with reducing friction and creating that film barrier. So it is also a common symptom of other problems. And so we'll get a little further into that later on, but that's just kind of a basic overview of what we're kind of getting at. So how is it measured? So the first way we're gonna look into is kinematic viscosity. That's how we measure it here at ALS in the tribology laboratories. And so that's measured in stenostokes. It's one of the more common ways to measure it. But kinematic viscosity is the internal resistance to flow under gravitational forces. So meaning that we'll drop a sample, and then it's going to flow down. And you can either have a capillary tube, or you can have kind of a curved tube. But for us specifically, and at least in my lab, and a more common one is in a capillary tube, so meaning that it's a very thin tube that you're trying to get through, but it's determined by measuring the time in seconds required for a fixed volume of fluid to flow a known distance. And so if we have it, we'll start at the top and we'll work our way to the bottom, and that's kind of a known distance, and we're timing that distance. And so that's how we kind of look at measuring the flow. And the temperature is controlled. If you control that temperature, then you can kind of control your stenostokes and your data, and know that it's comparable. And that's what we really get into is you want to be able to trend your history in oil. And so having those controlled variables help with that. So fluid viscosity is assumed to be shear rate dependent and shear rate is the rate at which adjacent layers of fluid move with respect to each other. So that's kind of like friction. And with kinematic viscosity, the two common temperatures we see are 40 degrees C and 100 degrees C. When we're determining which one we're measuring at, whether it's 40 or 100, it's based on kind of the oil type and the equipment that you're running. So these are Dare viscometers, and so they do use capillary tubes, and so the sample is injected at the top into these tubes down here. This is kind of, we have a few different thermometers that we use to measure it, but this is an overview of what the bath is. It's a contained system so that your temperature is really controlled. And then we get into our capillary tubes of what you see. So this is that top we saw where the oil kind of goes down. You can see in this picture that the top portion's a lot wider. It's what houses the oil. And then what you get it when you first inject it, I should say, and then you get into a much thinner kind of capillary portion. I've included this sensor over here that we use. So this first sensor sits right here and basically kind of holds allows pressure to be held so that we can control at the rate that we drop it. So we'll drop that oil sample into the tube, heat it to 40 degrees C or 100 degrees C, depending on which temperature we're running at. And once that temperature has been released, the pressure then releases so that fluid can start flowing. As you start to flow, you have these three sensors down here, which are all equidistant. The distance between it, so it times it between each sensor, and you can then get your viscosity and centistokes. And so this is that last portion, the very thin portion that you kind of see, and then it injects out the bottom. And so that's how we kind of look at our capillary tube and we measure that one. And so that's why it's gravitational forces. We obviously have pieces of our equipment that assist us in running it, so we don't just have to like put it in and then start a stopwatch and stop a stopwatch. So the other way that it can be measured is absolute viscosity, which is measured in centipoise. That one's generally performed in a rotary viscometer and can be and is for extreme temperatures. And rotary meaning that it spins. So what you typically see with a rotary viscometer is that a spinning portion is dropped into a beaker full of oil, and then it starts to spin and it starts to measure its resistance to flow in terms of how well it's allowed to spin and things. It's an interesting setup, but our preferred method is definitely in centistokes. It's a more common one. So as you start to look at your 40 degrees C and your 100 degrees C's, it starts to kind of give a characteristic of our oil that can often be measured, but doesn't have to be measured, and is something that is typically given when you look on your product data sheets, and that's your viscosity index. And so what viscosity index is its relationship between viscosity and temperature. So if we look at this graph down here, we see that the viscosity can be measured at 40 degrees C or 100 degrees C. And what you'll do is you'll plot that point. And so let's say we've got an oil and we have 0 over here and 40 over here. When we measure that in centistokes, we plot a point here. Then we'll measure it at 100 C and we'll plot it here. And that slope of the graph is basically our viscosity index, because it's saying how much did your viscosity change when we increase temperature and when we decrease temperature. So it does have to be measured at 2 temperature points, and typically those temperature points are 40 and 100. And you have a viscosity range from 50 to 200 for common oils. You'll start to see that multigrade oils tend to have higher viscosity indexes and are typically above 100. And when we talk about a term like multigrade and straight grade, which we'll get into it a little more, is when you start to see is in SAEs, which is when you start to add that W. So now that we've started talking about multigrade and straight grade, we start to talk about the viscosity oil grade system. So the first one we're going to kind of get into is ISO, which is typical for your industrial oils. This one's really cool because the midpoint of each viscosity is a 50% increase above the previous grade. I've got a slide coming up next that'll really demonstrate that, and it helps, but the one that I have below as an example is ISO 15. So it is 50% higher than ISO 10. So if you take 50% of ISO 10, so 50% of 10 is 5, you add that in and you have your next grade, which is ISO 15. That's one of my favorite examples to do. It's very easy math. So for your industrial oils and your ISOs, it's based on kinematic viscosity at 40 degrees C. That's typically what we choose to measure it at. And then when you're looking at what your oil grade range, it should fit into plus or minus 10% of the midpoint. So we once again look at this 10. So we're going to say 1. So your range should be somewhere between 9 and 11. Engineers should understand roughly what you're dealing with in terms of pump size, gears, and other components that are required for these different viscosities. And so what you'll see when they're selecting one is that you'll get a, for slow moving gears, you want a thicker oil. And then for oils that are too thin, they don't provide adequate protection. And then gears that are very small and are very fast, you want kind of more of a thinner oil. This is kind of like your hydraulic pumps or even oil-filled bearings. And so what you typically see is that your ISO 32s, 46s, and 68s are used in bearings and hydraulic application. Your ISO 150s and 220s are often your indoor gearboxes. We start to talk about indoor and outdoor because your indoor temperatures can kind of be controlled more, where your outdoor temperatures are I guess you can't control. So if we talk about where I'm based in Phoenix, summers get very, very hot, and you don't always get to control what that temperature is going to. So when we also get into higher above that kind of 220, we start to look at your ISO 320, 460, and 680s, and those are typically found in worm gear applications. So we start to look at our different ISO grades. And so you see that we have our 32, 46, and 68, which we were talking about for the bearing and hydraulic systems. And so you see your midpoints, which it lines up exactly with what we're calling at the ISO grade. And then you start to see your viscosity limits, which once again are plus or minus 10%. And so we work our way up to some very thick oils, and we work our way down to some very thin oils. So they have a nice range, and it's very easy to see. And so you see ISO, and then you have viscosity grade. So just things along those lines are kind of what we're looking for that help. Then you can look at your SAE grade, which are typical for engines. They can be a mono grade or a straight grade, like mono and straight grade are the same thing. And then you can also see your multi-grades, which is when we start to introduce that W and a few other components into it. You also, the higher the grade, the thicker the lubricant. That's the same thing that we were seeing on the previous slide. And single grades are not improved by viscosity improvers. So when you start to look at your multi-grades, that's when you start to see that they've been improved by kind of viscosity improvers and things like that. So when we look at our multi-grade, which we're still in the SIE grade, it's just multi-grades are very functional. I want to spend some time on that one. We start to see that it's typically represented by something as 15W40. I know I have the answer on the screen, but W actually stands for winter. It's a common misnomer where a lot of people think that it stands for weight, but the proper term is winter, meaning colder temperatures, things like that. So you also that's kind of where it goes. So viscosity changes as you do multi-grades. You start to see that your temperature changes less. So if we look over at this, I guess your viscosity changes less at lower temperatures. So when we look over at this chart, we have two different SIE grades going on here. We have our SAE 40, and this is kind of that chart that's been created based on like temperatures. And so you can see there's one at 40 and one at 100. And this is this graph that we're looking at, and the line that's created is based on the viscosity index. The same thing over here with your SAE 15W. And you can see that the SAE 15W works really well at cold temperatures, and you're starting to see that the SAE 40 does a little better at higher temperatures, because you do want to be operating at maybe a lower viscosity, because up here we get very thick. And so if you mix the two together, and I'm not actually telling you to take an SAE 15 and an SAE 10, mix it together, but if you create an SAE 10W40, you start to see that graph changes, and that's what we see with this red line. And you see that we are being able to look at a much broader range of temperatures and experiences it, and your viscosity index, the slope, and you kind of see it represented by the red line. And so the non-W will often provide how well an oil will operate in high temperatures. And so we're looking once again at this SAE 40. The W indicates how well that oil will operate during like engine startups or cold temperatures, and that's that SAE 15. So once again, those are created by blending low viscosity oils with viscosity improvers or pour point depressants to kind of create that multi-grade. So then we start to look at kind of the systems together and how they can kind of be related to each other. So we can see that we have our ISOs over here. We started our 10 and we work our way up to our like 1,500. You also see that we are looking at our Centi-Stokes in 40 degrees C and our Centi-Stokes at 100 degrees C. But you also have, so you have your ISO, your AGMA, SAE crankcases, and SAE gear cases. And I probably should have mentioned it earlier, but ISO stands for International Standards. And then SAE is Society of Automotive Engineers. And then AGMA is American Gear Manufacturers Associations. You tend to see AGMAs with older equipment. It's less common now. We do, and at least in testing, most of the viscosities I see are either ISO or SAE grade. Should you be measuring, and this is another grade that you can choose to do, which is Sabled. They also have it compared over here, but you can kind of start to see, and we'll look at this ISO 320. You can see that it's equivalent kind of to an AGMA grade 6 or an SAE crankcase grade 60. And then you can see, depending on where it falls, you're either at an SAE 140 or an SAE 90. And that's just kind of relating them all together. It doesn't mean they're the same thing. It just means that when you're looking at the viscosity at either 100 degrees or 40 degrees C, they have a similar viscosity. So as we've learned more about our oil and kind of what it does and what it is and how it's related, because all that information is very important to know how it's operating and to know what your viscosity should be operating at and what it should be coming in within range. As we test it, we start to either see that your viscosity can increase, decrease, or be where it's supposed to. So when we're looking at decreased viscosity, we have a few common reasons why, which are fuel contamination as the first one. Fuel contamination means that fuel is getting contaminated into your oil. And you'll start to see, and this is just an example, so it doesn't apply to every single one, but if 10% of diesel fuel motor oil, diesel fuel is in motor oil with, let's say it's SAE 30, it reduces your viscosity by more than 36%. So we look at what was 110 Centi-Stokes to 70 Centi-Stokes. And so that film thickness that's created kind of decreases. And so while you think and hope that yours is operating where it's creating kind of a really good barrier and it's got at 110 Centi-Stokes, you could be operating at 70, which could lead to further issues. Other issues that decrease the viscosity are refrigerant contamination. Believe it or not, one of the more common one is a thinner oil being added. So if you are operating kind of like a larger company or just by accident, you happen to purchase a thinner oil instead of the one that you regularly purchase, when you start to mix those two together, they're going to decrease your viscosity, and you're not just going to have one grade oil in there. You're going to almost have a mix, and you never know how those are going to mix. It is one of the more common problems that we kind of see when we look at viscosity being decreased, especially if the oil's been changed, or as we call it, topped off. Then you have solvent ingression. This is just for anything you're operating. So ingression just means it's being introduced into the system, whether all at once or steadily. You really just don't want that solvent in there. And solvent can range from just any type of fluid that you're working with. And then you have hydrolysis, which is water contamination. You definitely do not want water being introduced into your system. So those are a few things reasons that we would see a decreased viscosity. So the opposite side of decreased is increased viscosity. So when you have your increased viscosity, you start to look at soot contamination. So soot is caused by so it causes increased temperatures and slow flow of lubricants to the machine component created by incomplete combustion of diesel fuel oils. So then the same thing can happen. Instead of accidentally adding a thinner oil, you can add a thicker oil in, which is not good either. So when you add a thicker oil in, you should see increased viscosities. Once again, you don't ever want to mix things together because it starts to create scenarios where you're not sure if those oils are compatible. So you do want to make sure that you're topping off with either a compatible oil or an oil of the same grade or the same type of oil. We do have test seared ALS should you have a desire to start to mix them. I can add more information on that to see if they're allowed to be mixed, but I definitely don't recommend just adding in an oil that you're not familiar with into your system. So then you also see increased viscosities with glycol contamination, depletion of your light end of base stocks, also oxidation can cause increased viscosity. So oxidation can can occur because of aging, thermal abuse, meaning operating at higher temperatures than the fluid or the equipment recommends. And this could be that you start to see oxidation or thermal abuse, not because you personally are operating your equipment at a higher temperature or than the fluid recommends, but maybe because you have an outside problem occurring. Maybe you have an increased viscosity, so then you start to have thermal abuse occur. So it's kind of a which came first, the chicken or the egg scenario. You don't really know until you start to do that oil analysis on it, as well as emulsification. And that too just kind of means that water's been introduced, but this time the water's been introduced and mixed in. And so that water's not easily separated sitting on top, because you know how you say water and oil don't mix? Well, sometimes you get kind of a very cloudy and milky system that's going to occur. And then you know that your sample's really been emulsified. But that cloudiness is can be an indication of emulsification. It can also be an indication of a few other things. You definitely want to get that oil tested to kind of see what's going on there. So I took all of that, and this is a chart some of you might have seen before, maybe not. We put it into just a common chart that our general guide for troubleshooting. So this is why your viscosity is increasing or decreasing. Please definitely refer back to this a few times. I had a few of our diags look this over with me in terms of what recommended corrective actions are. And so we're just going to kind of look over those recommended corrective actions. The problem causes were all addressed on the previous side, but when some of the corrective actions are checking how your cooling system is operating, checking your oil level. Believe it or not, if your oil's low, you need to top it off, and having a low oil can be just as bad as having like dirty oil, because it means that your oil is not properly lubricating your system and you're creating more problems. So then you also want to check the circulation. Is that oil making it through the system the way it should? Is anything stopping that flow? Then you also want to check for foam and air entrapment. When you start to work with equipment that moves very quickly or just relies on things, air entrapment can do just as much damage as a sediment that's in there. And so that foam created, you'll see, is where you can know that air is getting in, and air entrapment just means that air is kind of mixed within your oil. Sometimes you'll look at it and see it as bubbles. So if that's the case, you can look at shortening your drain intervals, eliminating air contamination wherever it is occurring. So if you have a system that air is going to get in, you're probably not going to have air entrapment. But if you have an enclosed system where there really shouldn't be air getting in, that's definitely one way to do it. You always want to check your oxidation inhibitor levels. If your oil does have them, you can check those by checking, 1, your oxidation level, or 2, running an ICP to see if those inhibitors are still in place, and then reducing high temperature operations. So if your equipment is like let's refer back to my car. If my car is outside, if I move it into the garage, I can reduce my temperature. It's not always that easy, but sometimes it is. You want to make sure that you've added sufficient oil grade to the correct oil viscosity. Once again, you'll see shortened drain intervals in there as well. Reduce idling, check engine for contamination. The reason shortened drain intervals is in there twice is sometimes you are trying to get the most useful life out of your oil. But if you're seeing that every time you're going to change your oil, it's not in a good condition, it might be something that you consider based on your own maintenance program, or even based on your oil analysis, that your drain interval does need to be changed. And sometimes it could mean if your oil is operating really well, you can extend that drain interval. But you do have to check with the OEM, with your product data sheets, as well as maybe shooting a quick message over to ourselves to ensure that it's right. You also just want to avoid any type of contaminations and try to reduce oil contaminants in your oil. So this is for increased viscosity. So then we look at decreased viscosity. So add sufficient heavier grade oil to correct viscosities. Once again, just making sure that your oil levels are correct. If it's too low, you want to change your oil. If you've got a contamination, you want to potentially look at changing it if you can. If there's a way to remove the contaminant, you can definitely look into it. And that's kind of what your system's operating and what your maintenance will allow you to do. So you want to select the correct oil. So if you're running it and you're seeing, and this decrease may be because of shearing, meaning that at your higher temperatures, they start to shear off, meaning that you might need to look at a different oil for your system so that it can withstand the temperatures that it's operating at, as well as looking at eliminating the sources of those high temperatures, whether that's contamination or maybe an issue that's occurring. So lastly, we have testing your oil sample, which is kind of just tying this all in a pretty bow. Why did we explain what oil that you use and all this information as well? So it's because it's just as is important to test your system, it's important to select the right oil, and so vice versa. So if you have the right oil selected for your system, you're testing it to maintain its level. Well, maybe you don't have the right oil for your system and you're testing to kind of figure out what is the right oil, or talking to your OEM, things like that. So it's very important, and testing your oil can tell you so much about your system, and it's so important because viscosity is one of the most important properties of oil. So an oil change can indicate larger issues with your systems, as well as it tells you that everything's operating well. Typically, if something's not operating well, you will see a change in your viscosity. One thing you do want to keep in mind, though, is when you are testing your oil samples, sometimes multiple issues can cover each other up. So if you have soot contamination as well as fuel in your system, you will see both a decrease and increase in your viscosity that could even themselves out. But if you're testing your oil and you're including other testing in it, like soot percentage, oxidation, nitration, you'll start to see those things that indicate that they're high. And they'll also be able to kind of look it over and say, oh, it seems that our soot is high, but our viscosity is normal. Why is that? What else is occurring with my system? So to get a little more into that, it's just basically saying that it's a very valuable tool as a primary test, but it also adds a lot of information as a secondary test. So if you are having your total acid number checked, it's going to lead some information to that system, or total base number. It's going to lead some additional information that's either confirming your results or something that basically says, okay, these ones are fine, but it seems that there's something else wrong with your system. So it's very important to test your oil sample, and viscosity is one of the things that you want to get checked every single time. It's also important that you're checking your oil at the right temperature. You're picking your 40 degrees C's for your ISO industrial oils, and then you're looking at 100 degrees C for your SAE and engine oils. That doesn't mean that you can't check your SAEs on at 40 degrees C, especially if your OEM recommends it or your product data sheet does. And those are acceptable things. And you can always call in and ask us these questions as well to help you out. But one of the things that I want to touch on and really emphasize as we draw to a close is providing your fluid information on your sample identification forms, or providing that information when you're testing. So when we start to test your viscosity, I've talked about how important a grade is when you look at it and what it's going to tell you about your information. But if you don't provide that with us, all we can provide you with are your results. You'll get a much better diagnosis if you are providing that grade information. It allows our diagnosticians as well as our team to know a lot more about your system and what you're operating. So then you'll also look at your manufacturer, and that's who's making your oil. The reason you want to do that is we can look at product data sheets and compare it to your results, as well as look at what your baseline should be and what it's recommended. Then when you start to look at it, I refer to it as the age of the oil, but you want to know the time and the miles of the oil. We want to know how long you've been operating it. If you just tell us, here's an oil sample, we don't know the grade, the manufacturer, or the time on the oil, all I can tell you what your results are, is what your viscosity is that we've measured it at, and things like that. But if you tell me that you're running an SAE 15W40 and that you've been running it for 3 months, 6 months, however long you've been running it, or even how many miles you've had on it, I can start to say it's recommended that you change your oil now, or yes, I am seeing fuel contamination in the system. This is my recommendation for changing it. We also want to see what's been done to your oil. Have you recently changed your oil? That all goes back to the time and the miles of the oil, because if you have recently changed your oil, your history on your sample is going to change. And that history is key, because we start to create a trend for you. You're going to see either things are staying steady, which are kind of just straight lines, or you can start to see things are increasing. And as certain tests or things increase, especially viscosity, sometimes the recommendation is to change it, or for viscosity, you can start to see that things are decreasing, and we'll refer to that as shearing. So maybe it's that your system needs, we might recommend that you go up a grade in your viscosity, because your thinner oil is just shearing out too quickly. A lot of these things are things that we can help you with, as well as if you provide your oil analysis to the OEMs of either your equipment or the oil you're working with, they can provide you some guidance and assistance with that. So those are huge things that I always like to push and let you know, as well as any maintenance performed. This one's key. I actually asked one of our diagnosticians if they thought anything else should be included, and that's what maintenance you're performing. Because if you've performed maintenance on your equipment and you've done something, if they know what you've done, they can help them either say what you did was good, what you did helped, or, you know what, I am seeing an issue with this, and I see that you did this maintenance. Do you want to double check and make sure that air's not getting in because there might not be a proper seal or something along those lines? So we try to help you guys out as much as possible and really get as much out of that testing as possible, because you're submitting your sample in. And the more information you provide and the more correct the information is, the better. I can tell you that I've had customers that have nothing on their SIFs and they fill it out, and we work the best that we can with. But the more information you provide on the system, the more valuable your results will be to you and to us. Thank you.